Graphing systems of linear inequalities in two variables. When we discussed systems of equations in two variables, we were looking for the point at where the two lines intersected on the graph. Now we're looking for the area that satisfies both conditions for the inequalities. In this case, we're talking about two conditions because we have two inequalities. If we have three inequalities, then we're looking for the area that satisfies all three inequalities. Okay, so we'll start with this first example. We're going to graph each of them at a time. X is less than or equal to -2. Okay, so let's graph x is less than or equal to -2. Recall that when we only have one variable, it's either a vertical line or a horizontal line. Since this equation has x, it's therefore a vertical line. So we're going to go to -2 on the x-axis, and then we're going to draw, it has the equals, so we're going to draw a solid line. If it did not have the equals, then we would draw a dashed line. Okay, at x less than, which direction are we going to shade? Right, we're going to shade to the left of the line. X less than, shade to the left. X greater than, shade to the right. Since it's less than, we're going to shade to the left. So we're shading to the left of this vertical line. Okay. Now let's go to the next inequality, y less than -1. Okay, when we have y equals -1, that's a horizontal line. Just go to -1 on the y-axis and draw your horizontal line. And it's dashed because it does not have the equal sign. So less than, we're going to shade below. So shade below the line. Now the answer is the area that was shaded twice. Well, and that is our desired region. So which area was shaded twice? It's this region really right here. We probably shouldn't have even shaded this, so always do so very lightly, because that's not the solution. The solution is the area that we shaded twice. So we'll go ahead and darken that a little bit more, just to indicate that that is our solution. If you wanted to, you could go back and erase this area, or probably don't even shade it to begin with, not so that there's no confusion. The answer to this graph, this system of inequalities, is this little square area. Now it goes on forever to the left and below, so there's lots of points here. That's just the part that we have on our grid. Let's do one more, a little bit more interesting. Okay, x plus y greater than 5 and 2x minus y less than or equal to 4. Let's start with our first inequality. So let's just go ahead and write it over here to the side. And we want to get y by itself, so subtract x on both sides. So y is greater than -x plus 5. Okay, you could use the slope and the y-intercept to pick points. First I'll write it as an equal sign. I'm just going to pick some points. Let's say 0, 1, and 2. There's no fraction here, so we can just pick 0, 1, and 2. But again, if you want to use the y-intercept, which is 5, and the slope, which is -1, so down 1 over 1, down 1 over 1, to get more points, that's fine. So let's pick 0, 1, and 2. If x is 0, y would be 5. If you put a 1 in here, that'll be -1 plus 5, that'll be 4. And 2, that'll make it -2 plus 5, which will be 3. I don't think we need to show the work, that's not too complicated. So go ahead and plot those points over here. Here's 0, 5, 1, 4, and 2, 3. Now we're going to draw a dashed line because there's no equal sign. And then it's greater than, so we're going to shade above. What I'll probably do is let's put some little marks on this side just to show that above is this region over here. So here's some little plus signs just to show that the desired region for this inequality is above the line right here. Let's write down our next inequality. And we want to get y by itself, so subtract 2x on both sides. Don't forget there's negative y. Now we don't want the negative there, so we have to divide all these terms by negative, so all the signs will change. Of course, when you divide by a negative, you have to invert the inequality symbol, reverse the direction. So now it's y greater than or equal to 2x minus 4. Greater than or equal to, that means what kind of line will we draw? Dashed or solid? Right, solid. And are you going to shade above or below? Above. So let's change it to an equal sign and then we'll pick our points. There's no fraction again, so I'll pick 0, 1, and 2. And I don't think we need to show the work here. If x is 0, 2 times 0 is 0 minus 4, that'll be negative 4. And if x is 1, 2 times 1 is 2. 2 take away 4 is negative 2. And if x is 2, 2 times 2 is 4. 4 minus 4 is 0. Okay, now plot your points on our grid over here. 0, negative 4, 1, negative 2, and 2, 0. And then we said we would draw a solid line. And we want to shade above. Well, here's our line, so above, everything above it, we'll put some little minus signs to show the area above. Okay, so all those points are above the line, all the little minus signs. Now our area is the area that satisfies both conditions. Well, which area has both little plus signs and little minus signs? Yeah, it's this top little region right in here between the two lines. So now we'll go ahead and darken that area in. And that's it, we're all done. So again, the solution is the area that satisfies both inequalities. If you were to take a coordinate that's in this area, let's say something like, let's see, 1, 2, 3, comma, 1, 2, 3, 4, 3, comma 6, about right here. If x is 3 and y is 6, if you put that into both of these inequalities, it would come out true. So let's see, what did we say? We said 3, 6. So 3 plus 6, that's greater than 5. And if you put a 3 in place of that x, 2 times 3 is 6. Minus, and we said y was 6. 6 minus 6 is 0. That's less than or equal to 4. So any point that you choose in this region would be true in both inequalities. Any point that's not in this region, so any of these other three little sectors here, would not be true in both of them. Might be true in one of them, but not both. Alright, so that's the end of this video on graphing systems of linear inequalities in two variables.